Hi, my name is Kelton Temby. I'm the founder of Eyesonhives. My talk today is, can computer vision monitoring see more than bees? When I was last in this ambulance, the Cleveland Clinic Mobile Stroke Unit, I was working on the telemedicine technology to help a remote neurologist diagnose whether the patient's brain is bleeding or has a clot. Obviously, it's preferable to do this non-invasively. We don't want to take the lid off the patient and look inside. A huge part of enabling doctors to project their expertise remotely is looking at the patient to really see what's going on. Expertise is understanding what the basic biometric data alone isn't saying. A picture is worth 1,000 words, and videos are 30 pictures per second. But not every situation is an emergency. In fact, medicine is trending towards unobtrusive, continuous monitoring. Preventative care means identifying problems well before they become emergencies. This is the key concept driving Eyesonhives. Effective patient and beehive monitoring needs to be able to observe over long periods of time, as well as enable an expert to use their own expertise directly to see what the data is not telling them. It's the combination of data and expertise that leads to understanding. Eyesonhives is a non-invasive visual monitor which uses an image processing algorithm to measure bee activity in front of the hive on the device itself. The data is stored on the device and uploaded to a cloud platform for later view. Video samples are also uploaded regularly, as well as highlight videos when bee activity of interest is detected. You can see the system can be powered by solar or another USB power supply. In the field, you can see things are a bit less glamorous. When Eyesonhives looks at a beehive, it is recording a video and counting the number of flying bees in front of the hive. You can see the algorithm tracking flying bees with the blue outlines. What's most surprising is that it's not just the number of flying bees in and out of the hive that matters, but the activity behavior patterns of the bees themselves, how they fly. The very first time we visualized a full day of beehive data, we observed a characteristic spike of activity in the early afternoon. This is actually the orientation activity of new field bees. New field bees means recently hatched bees, which means a recently laying queen. This is why the orientation activity is a good indicator of a healthy hive. No one had measured this before. No one had seen this before. A healthy queen and baby bees are the lifeblood of the hive. But if that wasn't enough to justify our naming, the waveform is a very familiar pattern. This is the heartbeat of a beehive. We found that if wind speed and temperature and humidity permit, all healthy hives have this activity regularly. The new field bees fly in progressively wider figure-8 movements in front of the hive, learning where they live. We observed that healthy colonies have this heartbeat activity most days, all over the world. The swarming spike is distinctive in that it is a much larger in magnitude when compared to heartbeat orientation activity. It generally occurs in the morning, and we now set activity alerts based on significantly exceeding the hive's typical heartbeat. We can compare reported swarms by looking at the data. Alternatively, we can apply basic beekeeper expertise and check the timelines. Easy to confirm this swarm. The robbing pattern looks like a sawtooth waveform. There's a ramp up in activity and a gradual ramp down. Video often shows bees fighting bees, and the time-lapse often shows wax cappings on the landing board as the robbers raid the hive. Eyesonhives help beekeepers understand activity trends and can objectively answer whether a hive is growing or in decline. This is particularly relevant when monitoring two hives within the same apiary, since seasonal and weather variations can be factored out. In this example, computer vision flagged a negative trend well before this was visually obvious to a beekeeper on the outside of the colony. The heartbeat spike had been in decline, and this hive had become queenless. We intervened by providing a frame of brood. The colony was able to raise an emergency queen, and you can see recovered over a period of a few months. In the past year, we've added a significant number of data sets to the Eyesonhives platform from beehives around the world. One of the questions we were curious to understand was whether bee activity patterns were global. This activity pattern shows beehives pollinating in the north of Finland, actually within the Arctic Circle. You'll notice it's the familiar heartbeat pattern. Who knew honeybees enjoy the long days of the Arctic summer? Latitude 66 North, summer of 2020. One fun anecdote was that monitoring bees in the Arctic Circle initially broke our weekly analytics mailer. Eyesonhives assumes it's monitoring beehive activity from sunrise to sunset. So when you're in a latitude that doesn't actually have a sunset, well, that was an interesting software bug to fix. Here you can see the heartbeat pattern in the late afternoon in Victoria, Australia, latitude 34 south, autumn of 2019. Finally, here's a familiar location of latitude 37 north in the heart of California almond pollination. Once again, we can see that settled bees show the familiar heartbeat pattern. We see all-day orientation typically when the commercial beehives first arrive. In another talk, we'll elaborate on the surprising amount of robbing activity we also observe in beehives and almonds. Perhaps if we can consider pollination effectiveness versus carrying capacity more carefully, we can maintain healthier colonies in almonds. You can see here an activity graph and heartbeat spike, but clicking into the video, we can apply our own expertise to see what's going on. Here at 9:52 a.m., we observed pollen coming in on field bees. We have a better understanding of what that point on the graph means. Now, taking a look at 3:54 p.m., we can confirm indeed that Eyesonhives is accurate in capturing a significant increase of bee activity. We can see pollen again, but also the different flight pattern of the orienting bees. We're also able to see if the hive was being robbed, if there were stragglers, even with deformed wing virus, but this was a healthy, boring example. Understanding a beehive's health and pollination strength is more complex than simply counting bees, but beekeepers can get a much more meaningful picture by observing bee activity at the hive entrance, even without disturbing the hive. So, where are we going with Eyesonhives? We remain committed to improving our three key focus areas: remote access, useful data, and easy interpretation. We're growing and curating the world's richest bee dataset. You can see in some of our numbers there. And more importantly, we're able to continually improve the software on the devices themselves through remote updates, as well as our cloud data platform and web app. In summary, the takeaways are: beekeeper eyes and expertise is more powerful than sensor data alone. Eyesonhives is a simple and scalable non-invasive beehive monitor. Eyesonhives enables auditing and expert review through the videos. Colony activity patterns are consistent around the world, and the heartbeat activity pattern is an indicator of queen and therefore colony health. One more thing, the Eyesonhives app will be publicly released during Western Apicultural Society, and the app includes a free augmented reality experience to visualize a beehive. We're aiming to support educators and backyard beekeepers via a fun, safe science education, literally in the living room. So check out the demo, download the app. Hope you enjoy. So thank you. Looking forward to taking any questions and hope you enjoyed the talk. Cheers.